What's going on, guys? Tom here, and in today's video I'm going to be teaching you how to create a super smooth third-person controller in the Godot engine. So let's get started. Okay, so as always, the first thing we're going to do is open up our Godot engine. I'm going to create a project here. I'm just going to call it third-person controller. We're going to create the folder and press create and edit. Okay, so we're going to click on 3D scene. I'm just going to rename this as always to world. And I'm going to start by saving that scene there. So let's create a folder for this. Let's call it scenes. And we're just going to save it as world. And we're just going to hit play so that we can define our main scene, world, hit play, and then let's close that out. Okay, so what we're going to do next is we're going to create the player. And to do that, I'm going to click on the tab at the top here, this add new scene button. I'm going to choose 3D scene, and we're going to call it player. I'm going to right click on the player, I'm going to click change type, and I'm going to change it to a kinematic body. And as always, you'll get this yellow triangle telling you that you need to add a collision shape. So we're going to do that, but first thing we're going to do is we're actually going to add a mesh instance. And you'll probably recognize what we're doing here. We're creating a new capsule mesh over on the right hand side. Trusty old capsule mesh. We're going to come down to transform and rotate it 90 degrees on the x-axis. Over on the left again, right click on player, add child node, and now we're going to add our collision shape. And on the right hand side where it says shape, we're just going to click on that there and choose capsule shape, and we're just going to set its transform to 90 on the X to match our mesh instance. Okay, so the next thing we're going to do is we're going to add the camera for our third person controller. Now to do that, I'm going to right click on the player and add a child node. And I'm actually going to add just a spatial node here, and you'll see why in a little while. I'll double click on that, and I'm going to rename it to camera pivot. We're going to drag this up to the top of our scene here, and right click on the camera pivot, add a new child to this, and now what you want to find is a spring arm. And you'll see here at the bottom it says a helper node mostly used in third person cameras. We're going to click create. Now what this spring arm does is it allows our camera to sort of sit, like it says, on an actual spring arm, which means that when it collides with like a surface or a wall, it's actually going to push the camera further towards the player so that the camera doesn't get locked behind the wall, and it gives us a really nice effect. And you'll see what I mean a little bit later on when I show you how it works in practice. But for now, we're just going to right click on the spring arm, and we're going to add a new child node to that, and now finally we're going to add our camera. We're going to come back up to the spring arm here, and on the right hand side you'll see that we have this spring length, and we're going to set that to about 5. Next thing we're going to do is we're going to move it up on the y-axis by about 1.5 units, and you'll see here that what that's done is it sort of pushed it up to where the top of the player's body would be. And you'll see as well in the 3D editor this sort of line here. Now that indicates the length of our spring arm. So if I change the length of this to say 10, you'll see that that gets longer. And what that actually means is that the camera element itself here, which you can see is right above the player, it's going to try and push that as far back as it can until it collides with something. Now, hopefully you can see my mouse moving here, but if, for example, there was a wall here, that's going to mean that the camera would get pushed back to here. It wouldn't go all the way back. It would come right up to here, which means that we're not going to get any clipping with walls and such. So we're going to change that back to 5, because I think that's just quite a nice value there. And what I quickly like to do is I'd just like to rename this spring arm just to camera boom, just so that it makes a little bit more sense. So let's save that, and we're going to go up a directory. We're going to create a new folder, and we're going to call it player, and then we're going to save this as the player. Okay, so now it's time for us to start writing our actual third-person controller script. So we're going to come up to the player, right-click, attach a script. We're going to save it as player.gd, and I'm going to remove all of this here, and we're going to start off by declaring some variables. So we're going to say export var speed, and we want this to be a float, and we're going to set it to about 20. We're going to have an acceleration. Again, this is a float, and for now we're going to set this to 15. We're going to have another variable here called air acceleration. Again, this is a float, and we're going to set that to 5. We're going to have another variable, gravity. float again, and we're going to set this to 0.98, which is roughly real life gravity. Another one here is max terminal velocity. Now this is going to determine how fast the player can fall at max speed. Again, this is a float, and we're going to define that as 54, which is roughly terminal velocity for an actual human. Another one, jump power. Again, float, and we're going to set that to 20. So all of those variables are specific to the actual movement of the player, so its ability to run and jump and fall. We're going to define some variables now which will also allow us to manipulate how our camera works. And for those, I'm going to say export, and we're going to put brackets here. Now what this is going to do is it's going to allow us to define some hints for the inspector window so that we have a bit of a nicer editing experience within the inspector on the right hand side, and you'll see how that works in a little while. So for this, we're going to say that we want this to be a float, and we want it to have values between 0.1 and 1. And this is going to be var mouse sensitivity. It's a float, and we're going to default it to 0.3. We're going to define another one here. Again, we want to hint to the inspector that it's a float. We want it to start at -90 and end at 0. And this is going to be var min pitch, so how much the camera can pitch up and down. This is going to define the lower limit of that. So this is a float, and we're going to say we're going to default it to -90. And we're going to do the upper range of that. So again, float, this is going to start at 0 and end at 90. I'm just going to call this max pitch. It's a float, and we're going to default it to 90. So we want basically 180 degrees by default of pitch rotation. However, I thought it would be quite nice to add this in because actually I quite like to limit it to about 80 degrees either side. It just means that you can't go fully vertical both directions, and it just gives a little bit of a nicer experience in my opinion. Okay, so a couple more variables we're going to add in here are a velocity, and this is going to be a vector 3. So we want to keep track of what our current velocity is at all times so that we can modify it. And another one here, y velocity, and this is going to be a float. Now the reason I'm separating out velocity and y velocity is because we want to make some tweaks to our actual height, our y velocity value, based on things like gravity and whether or not we're currently jumping or if we're on the ground. So it's just a little bit easier. You can probably do it in a different way, but it's a little bit easier in my opinion just to keep track of that y velocity as a completely separate variable. And that means when you're multiplying your direction velocity by things like delta time and your current walking or running speed, you're not modifying and messing about with that y velocity there. It just makes things a little bit easier. Okay, and now what we're going to do is we're going to get some quick references to some elements within our player. To do that, we're going to say onReady var camera pivot equals camera pivot, and an onReady var camera equals camera pivot, camera boom, camera. There it is. Okay, so that is a lot of variables. Let me just quickly run through each of them. A lot of them are self-explanatory, but let's just run through them again. So we've got our speed. That's just going to define the speed that our character walks. Our acceleration is the rate at which our character reaches his maximum speed and then slows down again when the player lets go of the input keys. Air acceleration is one I've added in here. I think it gives it a really nice feel when you're jumping in a third-person game to not have the same amount of control with regards to things like strafing and moving back and forward when you're in the air. I don't feel like it feels realistic enough to be able to jump and then sort of strafe around just like you would when you're on the ground. So I like to add air acceleration in here and reduce its speed a little bit. So that gives you a little bit less control when you're in the air. However, I feel like it feels a bit nicer. We've got our gravity, which defines the rate per second that we're going to fall. We've got our maximum terminal velocity, and that is going to determine how fast we can fall at our top speed. Our jump power is just the power of which we jump. And again, these ones are pretty self-explanatory. Our mouse sensitivity for looking left, right, up and down, and our minimum and maximum pitch that the camera can be at. Velocity and Y velocity are to keep track of our current speeds, and these camera pivot and camera just give us a quick reference to some elements within the left-hand side here within our player's tree, just so that we don't have to type these out every time we want to reference them. Okay, so let's kick this off with a func ready. And inside here, the first thing we're going to do is we're going to capture the mouse so that the mouse disappears and it's locked to the window. That means when you're moving the camera left and right, the mouse isn't going to go outside and you're not going to click on things behind the window. So to do that, we're going to type input.set mouse mode, open our brackets here, and we're going to choose mouse mode captured. Okay, and because we're capturing the mouse, we also want a way to release the mouse. So we're going to define our ready function, our process function here. And we're just going to check every frame. We're going to scroll down a little bit here. We're going to say if input.isAction just pressed, and we're going to use the UI cancel method here. Let me just hide this output window so we've got a bit more space. So if we press the UI cancel button, which defaults to the escape key, then we're going to release the mouse. So we're going to say input.set mouse mode, and we're going to set that back to visible. All right, so now we've got our mouse being captured and released if we press the escape key. It's time to start handling the mouse movement. To do that, we're going to use the input function, so the input event function there. And we're going to say if the event that we're getting passed is an input event mouse motion, then what we're going to do is we're going to say the rotation degrees of this object, so rotation degrees dot y, and we're going to subtract from this value. What we're going to subtract is our event.relative.x, so how much the mouse has been moved on the x-axis. We're going to multiply that by our mouse sensitivity. And then to do our pitching, you'll see now why we've got the camera pivot. We're actually going to use the camera pivot to do the pitching with. And again, if you've followed my first person tutorial, you'll realize that you can run into a bit of an issue when you're doing rotation on the X and Y axis in 3D, where you can have gimbal lock, or you can also have it just going completely out of whack when you try and rotate the same object on two different axes. So we're separating this out with the player itself doing the horizontal axis and the Y axis, and the camera pivot is going to control our X axis rotation. So for this, we're going to say camera pivot dot rotation degrees dot X. So we're going to rotate this on the X axis. Again, we're going to subtract from that value, and we're going to do event.relative.y. So depending on how far up and down you've moved the mouse, that's going to control our pitch. Again, like we did above, we're going to multiply that by our mouse sensitivity. And then we're going to clamp that value so that it sits in between our min and max pitch. So to do that, we're going to say camera pivot dot rotation degrees dot x equals, and then we're just going to call the clamp function, and we're going to pass in our camera pivot dot rotation degrees dot x, and we're going to give it our min pitch and our max pitch, and that's going to clamp it to whatever we've passed in for those two values. Okay, so we're going to save that. And what we're going to do is we're just going to quickly jump back to the 3D view here, and for our player, we're going to come down to the collision tab here, and we're going to actually change the layer that this player lives on. Now, before we do that, we're going to come up to project settings here, so project settings, and we're going to scroll down, and under the layer names option on the left hand side, we're going to choose 3D physics. Now, I'm going to create some layers here. I like to have layer 1 as all of the environment, so things like walls and floors and basically collidable objects. So for that, I'm just going to call it environment. And then on layer 2, I'm going to call it player. So we want our player to be on a separate layer because the camera spring arm, we don't want that to actually interact with the player itself. That's going to cause some very weird issues with the camera. So what we're going to do is we're going to close that, and we're going to come over to our player here on the left hand side. Now we're going to come over to the right hand side here and click on these two dots. And if you don't see the layer names that we just provided before, what you can do is simply save this player scene, close it, and then reopen it again. Click on the player, and if you come over to this on the right hand side now, you'll see that they've actually loaded in. I think it's a slight bug or glitch with the Godot editor, but it's a relatively quick fix. So what we're going to do is we're going to untick environment, and we're going to choose player. So we're going to come over to camera boom here, and we're going to look at the collision mask on the right hand side, and we're going to make sure that the only thing that this spring arm is concerned with colliding with is the environment. We only want it to collide with things like walls. we don't want it to collide with the actual player itself because that's going to cause issues with the camera. So we're going to save that. And now what we're going to do is we're going to come over to our world. You'll see that I've dragged in the player scene here. And we're just going to press play and we're just going to test out our mouse controls. So you'll see that we're able to go fully left and right, and we can also look up and look down, and we're limited to that 90-degree axis there. So if I close this, and on our player, if we change this max and min pitch to, let's say, -50 and 50, and we press play, you'll see now that we're limited to a 50-degree pitch either side. We can't go all the way up and all the way down again. And I just think that actually having something like -50 and 50 is just a little bit nicer than being able to go fully underneath the character. It just sort of means that your camera doesn't end up colliding as much with things like the ground and anything that might be above the character. But that's completely up to you how you want to do that. Okay, so let's go back into our script, and now what we're going to do is we're going to add in the code that's going to define the movement for our character. So actually, before we start jumping back into the script, let's go back into our project settings, and let's go up to our input map here, and let's define some inputs. So we're going to type move forward, move backward, move left, and move right, and finally jump. Let's define these, so let's click the plus button, choose key, forward W, backwards S, left is going to be A, right is going to be D, and jump, we're just going to choose the spacebar. Okay, cool. So now it's time to define our movement. What we're going to do is we're going to say in func physics process, we're going to call a function called handle movement. I just like to separate out functions into these nice little chunks so that they're a bit more descriptive. And then we're going to define our handle movement function. We're going to give it our delta. Okay, so it's time for us to work out what direction the player wants to go in. To do that, we're going to define a variable, var direction, and we're going to default it to a blank vector3. And now we're going to have a series of if statements, just like you'll have seen in the first person controller tutorial. We're going to have if input.isActionPressed, and we're going to use move forward. If that's the case, we're going to say direction minus equals transform.basis.z. So that gives us the forward direction for this player. We're going to add that to the direction vector, or in this case, we're going to negate it because negative z-axis in Godot is actually forward. We're going to have if input.isActionPressed, move backward. We're going to do direction plus equals transform.basis.z. And what we're going to do here is we're actually just going to copy, paste these in, and we're going to change that to move left. And for this, we're going to do minus equals transform.basis.x. And on move right, we're going to plus equals transform.basis.x. Okay, so once we've done that, the final thing to do, as always, is we're going to normalize our vector. So direction equals direction.normalized. And that means that if you're pressing the forward and left key at the same time, so you're going diagonally, you're not going to be going faster than if you were just going forward or backwards, or left or right. So we're always going to normalize our vector to have a length of 1. And now this is where we're going to start doing our acceleration and actually trying to interpolate our current velocity. So we're going to get a variable here that defines how fast our acceleration is, depending on whether or not we're on the floor or we're in the air. To do that, we're going to say var, I'm just going to call it accel, equals, so we're going to say it's our acceleration, so this variable here, 15. So we're going to say it's going to be acceleration if is on floor, which is a function that you get in a kinematic body, which this node inherits from. So we're going to say we want our acceleration to be the acceleration value if we're on the floor. Otherwise, we want it to be our air acceleration. So if we're on the floor, it's going to be 15. Otherwise, it's going to be 5. And now we're going to do velocity equals, and we're going to do some linear interpolation here. So we're going to say velocity dot linear interpolate, and we're going to give it the direction and speed that we would like to be going at. So that is our direction multiplied by our speed. And how fast are we going to accelerate towards that speed? Well, we're going to accelerate towards that at accel multiplied by delta. Okay, so now what we're going to do is we're going to add in our gravity. To do that, we're going to say if is on floor. So if we're currently on the floor, we actually don't want to apply our full gravity, because if we do that, what's going to happen is when we actually come off a platform eventually, we will have been adding gravity over time, and it's just going to keep growing and growing and growing and growing. And eventually, once you do step off a platform, it's going to be at such a high value that you're just going to plummet instantly, and we don't want that to happen. However, with a kinematic body, if we don't apply gravity like this all the time, we're going to get some really strange issues with the is on floor function. What I've noticed is, especially with a capsule collider, every now and again it will report that you're on the floor, and then sometimes it will report that you're not on the floor if you're not constantly applying some minor negative y axis. So what I'm going to do here, I don't know if this is a well-known thing or if people normally do this, but it seems to work for me. What I'm going to do is I'm going to say that our y velocity is actually going to be equal to negative 0.01. Now that just applies a very, very minor amount of downward force to the player when they're on the floor, and I feel like that just sort of pins them to the floor, and that seems to fix any issues that you get with is on floor. Now you can also, I've heard, use the move and slide with snap function. However, I've found some issues with that as well. So I just like to brute force it really and just say, look, if you're on the floor, apply a very minor amount of downward force to make sure that you're pinned to that floor. Sorry, that was a really long rant. But basically, we're going to say if you're on the floor, apply a very minor amount of downward force. Otherwise, we want to apply our full gravity force. So to do that, we're going to say y velocity equals, and we're actually going to clamp this value. So we're going to clamp it to our current y velocity minus our gravity force, and we're going to clamp it to between negative max terminal velocity and positive max terminal velocity. And what that's going to do is it's going to apply a gravity force over time, but it's going to limit it so that you can only ever go at that maximum terminal velocity, which we defined here as 54 units a second. Okay, and finally, we're going to define our jumping functionality. To do that, we're going to say if input.isActionJustPressed jump, and we're currently on the floor, so we only want them to be able to jump if they're currently on the floor. Then what we're going to do is we're going to say y velocity equals our jump power. Okay, so that seemed like a lot. There's just 2 more lines of script and then we are done with this script. We're going to say our velocity.y value is equal to our y velocity. And then finally, we're going to say velocity equals, and this is where we do the actual movement, we're going to call move and slide. We're going to give it our velocity value, and we're going to tell it the up direction, which is vector3.up. Okay, so that was a lot of code. Let's briefly run through this. So inside our handle movement function here, let me just scroll back a little bit. We're defining a direction variable. We are checking our input for forward, backward, left, and right. And we are adding to our direction variable. And we're using our transform.basis, which gives us the direction of this current player. So we're going to use its Z and X values to determine our forward, back, left, and right there. We're normalizing the direction value so that if you're going diagonally, you're going to be moving at the exact same speed as if you're moving forward. We are working out whether or not we're currently on the floor and determining what acceleration we use. So the faster acceleration if you're on the floor, or a slower acceleration if you're in the air. Then we're using some linear interpolation to work out our ideal speed based on the player's input, and then accelerate up to that speed over time based on our acceleration value. Next, we're checking for our gravity. So we're going to say if we're on the floor, we're only applying a minor amount of downward force to clamp us to the floor there. Otherwise, we're going to apply the maximum gravity by subtracting the gravity force over time from our velocity, and we're clamping that to the maximum terminal velocity so that we don't fall too fast. Then we are checking whether or not the player has pressed the jump key, and if they're on the floor, then they are allowed to jump. We're going to apply our jump power to the Y velocity. Next, we are setting the Y value of our actual velocity vector 3 up here to the Y velocity that we calculated. And finally, we are calling the move and slide function with our velocity with all of its forward, back, and upwards values calculated, and we're giving it our vector3.up. Okay, so that is basically our complete third-person player script. So let's create a little world for the player to jump around in and test this out. We're going to come back into our 3D scene. In our world scene, let's add a child node to the world, and I'm just going to use a CSG box here. CSG boxes are just really quick ways to prototype out an environment. What we're going to do is we are going to scale this out using these little red boxes here. Let's scale that, and on the right hand side we're going to check use collision. Let's move that down a little bit to below the player. And I'm just going to define a material here. So on the right hand side we're going to give it a spatial material, and let's give it a color. Let's give it a nice red color here. And then we're going to duplicate this with Control D on the left hand side. We're going to scale that in. Let's make a little platform here, move it up a little bit, and let's actually scale it that way, scale it this way, scale it that way a little bit more. Let's move it over. Okay, let's duplicate that and let's move it over this way. And I'm just going to create a series of platforms that hopefully the player is going to be able to jump on. Let's move that. Let's duplicate that again. Let's move it up, move it across this way. This platform's actually a little bit too high, so let's move these all down a little bit. We could actually also just increase the jump power on our player itself. We're going to press play, and now you'll see that we are able to jump around on these platforms nice and smoothly. So one thing I'm going to do quickly is I'm going to select all of these and come into the material. Let's define a new material for it. Let's give it a blue color. Oops, we chose the same material. Let's create a different material for the floor. Let's go back to a red. And let's just create a wall here so that I can show you the camera boom arm. So we're going to create a thin wall here. Let's move it across to the right hand side. And let's give it a different shade of material as well, just so that we can see it a little bit better. Let's give it a green. Oops. Okay, I didn't choose green, but there we go. Let's press play. Okay, so now if we walk up to the wall, you'll see that the camera is fine. However, if we move around, what you'll notice is that the camera zooms into the player so that it doesn't collide with the wall. Now, you might see a little bit of the mesh there. That can be fixed with various things such as near clipping distances. However, I won't go into that in this tutorial, but it's just to make you aware that that spring arm is functioning properly and it is zooming into our player there. And if we walk forward, you'll see it comes out to the 5 distance again. If we move back towards the wall, the player gets closer. And that's it. We've created a very simple third-person controller with full mouse movement, pitching up and down, left and right, and we've got some really nice smooth jumping and movement controls here as well. If you like this video, please click that subscribe button and hit the little notification bell to be notified when I release new content on the channel. I release new videos every Monday, so make sure that you don't miss out. If you'd like to support this channel, I have a Patreon account and I'd really appreciate it if you checked it out. You can download the resources for all the things you've seen in today's video, as well as all the resources for every other video on the channel in my GitHub. Link is in the description below. As always, thank you so much for watching, and I'll see you guys in the next video.